At the top of page 574, you're going to have the following instructions. Solving, we'll call it the general solution. So that'll be our title. What's going to happen is sometimes they're not going to tell you the domain is between 0 and 2 pi. They're going to tell you the domain is everything. And they might write it like this: theta belongs to all real numbers. If they wouldn't state any domain, this is what would be assumed. You're solving for all theta answers. So what are we going to do in this case? Well, the steps are quite simple. You're going to solve like normal from 0 to 360 or 0 to 2 pi, just like you would before. And then, just like we did in the last chapter, now that you've found those answers between 0 and 2 pi, in order to find all of the answers, you're just going to have to write down all the coterminal angles with those angles you found between 0 and 2 pi. And if we remember, how do we write all the coterminal angles with pi over 6? We do pi over 6, and then we'd add 2 pi as many times or subtract 2 pi as many times as we wanted. So you could go 2 pi times k. If the answer was 11 pi over 7, and you wanted to write all the coterminal angles with that, then you could add or subtract 2 pi as many times as you wanted. So what we're going to do to write all the coterminal angles is we're going to add k times 2 pi, and the way that we often write it is we put the k in between the 2 and the pi, even though I think based on logic, I like the k in front of the 2 pi because it's really obvious that you're going all the way around the circle. Mathematically, it's often written more as plus 2k pi. And then you have to say add 2k pi, and a k has to be an integer to each answer. So we're going to add that 2k pi plus 2k pi to each answer. So we're going to solve it like normal from 0 to 2 pi, and then we're going to add 2k pi to each answer. So you've written this at the top of page 574. In question number 1, I'd like you to just put an X through that because we're going to make our own example instead. And our example that we're going to do is going to be solve for theta, where theta can be any real number in the following question. Seven sine theta plus 1 equals 0. So we start this the same way. We solve it from 0 to 2 pi, just like normal. How do we solve this from 0 to 2 pi? Well, we get sine by itself, move the 1 over, divide by 7. Is that on our pi plate? No. So we got to go to our calculator. We have to find our reference angle. You could draw the pictures to help you, but the reference angle will be when we do sine inverse. And if we're thinking about the actual triangle, all the values will be positive. So we'll do sine inverse of 1/7. And you get a reference angle of 0.143. Dot, dot, dot. So then our answers between 0 and 2 pi, there's going to be 1 in quadrant 3 and 1 in quadrant 4, because our original sign is negative 1/7. So we go pi plus our reference angle, and we get 3.28, rounded to 2 decimal places, and 2 pi minus our reference angle, 6.14. Now those are our answers between 0 and 2 pi. When we're trying to write our general solution, we'll often write it like this. We'll use, since we have more than one solution, we'll use these squiggly brackets. You'll start with 3.28, and then you have to add 2k pi. 6.14, and you'll have to add 2k pi. Where k is an integer. So this is just a format to show that it can be more than one answer, and each of the answers that you get from 0 to 2 pi, you're going to add 2k pi to, where k is an integer, to show every single coterminal one with those ones. And that'll be all the solutions in all the real numbers.